Hello, my name is Manav. This is Algebra. Hello, my name is Manav. This is Unit 2A, Lesson 1 and 2 of Algebra 1 Honors or Integrated Math 1 Honors, rate of change of linear functions, and identifying slope from points, tables, graphs, and equations. Now, just for some vocabulary review, the rate of change is how much an output changes after the input increases by 1. So essentially, how much y changes after x is increasing by 1. If you do not understand rate of change, I strongly recommend that you check out the previous video under this channel where I talk about rate of change as a whole, and it's titled Unit 1, Lesson 12, Average Rate of Change of a Function. I strongly recommend checking that video out and understanding rate of change before coming to this video to learn more about slope. Now I want to talk about a new word that is going to be introduced. I may have subtly talked about it in previous videos. However, here I'm going to go very in-depth into what this is. I'm going to talk about the word linear function, and we're going to break this word apart so that you can better understand what it's supposed to mean. In the word linear function, we have the words line, and of course the word function. Line meaning that it's something that's found on a graph, and it is a perfectly straight line. That's a way to remember if something is a linear function, it is a perfectly straight line no matter what. So it is just perfectly straight across. It does not have any discrepancies in the middle. Now, a function means that every x value has a different y value. And as you know about functions, functions can be found on graphs. So essentially, this linear function means a straight line where each x value has a different y value that can be found on a graph. Here are just some examples of do's and don'ts in linear functions. So these are possible examples of linear functions. It is a perfectly straight line throughout. All three of these are. Each x value has a different y value if it was to put it on a graph. And these are totally believable lines that you could possibly see on a graph at any point. Now here are some examples of nonlinear functions and why they're not linear functions. If this line here has a curve in it, and that's why it's not a linear function. A linear function would look like that. And this is called an exponential function. And then a straight line wouldn't work either. Now you may be thinking, why doesn't it work? A linear function is just a straight line, is it not? Well, yes, you would be correct. However, this is not a function. It passes the linear part, but it does not pass the function part. So I'm going to go ahead and do the vertical line test. If you don't know what the vertical line test is, I strongly suggest you check out my video about identifying functions. But doing the vertical line test, as you can see, the black touches our straight line in more than one place. So that's why this is not a linear function. In fact, this is not a function at all. It's just a line. And then lastly, we have this. This is called an absolute value function. And this doesn't work for two specific reasons, and one is going to make sense a little bit later. The first reason is that it's not a straight continuous line. It has a discrepancy in the middle, and that discrepancy or vertice is right here. And another thing that we're going to talk about in a little bit is that each interval has a different rate of change. So if we were to find the rate of change if this interval versus that interval, you would have different rate of changes. This one's downwards, this one's upwards. They clearly look very different. And that's going to bring me to our next point, where I talk about what slope is. In a linear function, the rate of change is the same throughout, no matter the interval. So you can have 4 random points, and each 4, no matter which 4 that you calculate, every single one will result for the same answer. And we call this a slope. So I'm going to show an example right here. Here's A, B, C, and D. If you were to find the rate of change between A and B, A and C, or A and D, it would all be the same rate of change. If you were to find the rate of change between, let's go with point B. If you were to find the rate of change of point B to C, B to D, it would still be the same as anything else. If we were going to find from C to D, all of these humps that I have here have the same rate of change. They are all equal rate of changes. And this is only applicable in a linear function, so any function that is a straight line. And this is the rate of change in a linear function is what we call a slope. The slope is what's equal through all intervals of a linear function, and not the rate of change is slope in a linear function. Now, finding slope is essentially simpler than finding the average rate of change. The methods that we used in the previous video still work, and I will demonstrate that throughout this video. However, this slope method, a method that only works for slope, works a lot better because it is a lot easier, especially for graphs and equations. And here's another thing that you got to keep in mind. A formula that we have to consider is change in y divided by our change in x. And this is only applicable for linear functions and slope only. And why does this work, you may ask? Well, if you recall, our previous formula is y2 minus y1 over x2 minus x1. Essentially, what you're understanding is that you're finding the difference between the two y's and the two x's. And that difference is the change in between your two y's or your two x's. For example, if this is 10 and this is 5, your answer is going to be 5. So your change is 5. You're changing this number by 5 to get to your second number. And the same thing with x. Let's say this is 9 and this is 6. We're changing by 3. We're adding 3 to get from number 1 to number 2. Hopefully that does make sense. Now I'm going to show you how to find slope from just two regular points. Now there are two methods to do these, as well as there are two methods to do all of the problems I'm going to show in this video. So one thing that we have to keep in mind, because this is a linear functions video, all of our examples are linear functions. So please keep that in mind. If you're ever given on a test, you need to make sure that the numbers and values given to you are from a linear function. Please make sure of that. Now I'm going to call, there's two methods. Method A is going to be our rate of change method. This is what was in our previous video, and this is what you would normally use if you have not seen the methods in this video. Now we have version B, which I like to call the shortcut method, and this is only applicable for linear functions, like the one we have right now. So normally what we do is we would identify the 2 points, and we would identify x1, y1, x2, and y2. We normally do that by just reading straight across and just giving each one an assignment. Next, we would take those numbers and we would plug them into our formula, which is y2 minus y1 divided by x2 minus x1. And then when we plug in each number, 10 for y2, 5 for y1, 2 for x2, and 1 for x1, we would get 10 divided by 10 minus 5, which is 5, divided by 2 minus 1, which is 1, 5 divided by 1 is 5. This should really feel very similar and This should feel very normal and very comfortable. If this does not feel comfortable, I strongly suggest that you understand rate of change before you look at this. However, this may make it simpler for you, so it is solely depending on what you seem makes more sense to you. I'm going to spend less time on rate of change in this video, so if you feel the need to emphasize more on rate of change, please check out my previous video. I go into depth about rate of change. Next, I'm going to show you my shortcut or the slope-only method. This only works if the points are identified as linear, and you're given to find the slope. You're going to do the same thing. You're going to identify x1, y1, x2, and y2 by just reading straight across. But then you're going to set it up so you have x1 and x2, and then y1 and y2. You're going to set it up exactly like that. You're going to have x1, x2 next to each other, y1, y2 next to each other. Next, what you're going to do is you're going to find the change, like we talked about before. You're going to find the change between the two numbers to get from number 1 to number 2 for both of them. 1 plus 1 is 2. 5 plus 5 is 10. So our change in x is 1, and our change in y is 5. And remember, our formula is change in y divided by our change in x. So we put our change in y on top, divide it by our change in x, which gives us 5. And if you have not noticed, 5 is equal to 5. So that means both methods work, but you can choose which one you think is simpler. Me, personally, I think this one is simpler, but again, that is up to your taste and preference. For the sake of this video and staying on topic, I am only going to be using method B for all 4 explanations that I have. So now we're just going to solve, assuming that is linear, we're going to solve for this problem. First step is to identify x1, y1, x2, and y2, and we're just going to do that by reading straight across. x1, y1, x2, y2. Next, we're going to set up our numbers. I'm actually going to do it in reverse to what I did before. I'm going to put y on top and x on the bottom, and I'm going to do y1, which is 8, is to y2, which is 24. And we're going to do the same thing for x. x1 is 3, is to x2, which is 5. Now we're going to measure the change between the two. 8 plus 16 equals 24. 3 plus 2 equals 5. So our changes, our change in y, this is just my abbreviation for change in y, is 16. Our change in x is 2. Our formula is change in y divided by change in x. 16 divided by 2, just same numbers, which is equal to 8. So our slope for this problem, our average rate of change for this problem is 8. Hopefully that made sense. Now we'll move on to tables. Again, we're going with the assumption that since this is a linear video, we're going with the assumption that the table shows linear plot points. So these are values that are found on a linear graph. Method A, which we are normalized to, is we have to identify x1, y1, x2, and y2 to 4 different values. We do that here. And then we set up our equation like normal, and we plug in each value, where we are ended up with 2. Again, I'm not going to elaborate on this method too much. If you still need help with this method, please check out my previous video. But I just identified 4 numbers to these 4 values, plugged in each value to replace each placeholder, and then solved like normal. Now we have method B. Again, we're measuring the change in y divided by the change in x. And one thing to remember is that no matter what the interval is, so no matter what x and y values you choose, you're going to have the same rate of change. So I could choose these 4 numbers like I did. I could choose 3, 6, 5, and 10. I could choose 1 and 2, 5, and 10. I can choose whichever numbers I want that are given to me. Just for the sake of time, I did the first 4 numbers. So we can get rid of this number. We don't need it. What I did is I measured the change in x, so what it takes to get from number 1 to number 2, and same thing on both sides. So I did that for x and y. 1 plus 2 is 3. Our change in x is 2. And 2 plus 6 is 4. Our change in y is 4. Our formula is our change in y divided by our change in x. 4 divided by 2 is 2, and that is the same as what we had before. Again, for this method, I honestly think that both of these work. I think they're both really good methods. But again, just for the sake of this video, I'm going to show you only method B in our practice problem. Again, please feel free to do method A when we do these practice problems, but I'm just going to show you how to do method B. So first, what we're going to do for our values is we're going to take any numbers that we want. I'm going to just use the first 4 again, because me personally, I think that's a little bit easier than to jump around with bigger numbers. So we're going to get rid of this guy. Next, what I'm going to do is I'm going to find out the change in x and the change in y. So this number is our change in x, and this is our change in y. 3 plus 4 is 7. 8 plus 4 is 12. Our formula is change in y divided by our change in x. When we replace the numbers, we have 4 divided by 4, which is equal to 1. This means that our slope, or rate of change, is 1. Next up, we have graphs, and I strongly suggest for this one that you use the slope method. It is so much easier, and you have to do little to no math to actually solve this one. So for method A, which is our rate of change method, it's significantly harder. It's unnecessarily harder. But what we would do is first we would identify 2 points. I did this one and this one. When I wrote them out down, I got -8, -8, and -6, -4. Again, we'd write down x1, y1, x2, y2, just going across. We would substitute each value for its placeholder, and then when we would solve it out, we would get 2. Now, our easier method is something that we call rise over run. You stand up before you walk. You go up floors in elevators before you walk out onto the floor. However you may remember it, you're going to learn something called rise over run. Our rise is y and our run is x, and I'm going to show you why that works. And to keep in mind, the number of times that we go up is our change in y, and the number of times we go to the right is our change in x. Right or left, up or down, but I'm only going to go up and right. First, what I did was I identified our start and our end points. So that's this one and that one. First, what I did is I rised. So this means that I figured out how many hops it would take for me to get to this level, because this is our end point. So I went up 2, because it took me 2 to hit this line. And then I did the same, but vertically. It took me 1 hop to get here. So our rise is this, and our run is that. Our rise is our change in y, and our change in x is our run. Our change in y was 2, our change in x was 1. 2 divided by 1 is 2. And that's what I do down here. Now we're going to do it again over here. I already identified our start and end just to make it a little bit easier for us. Our start is here, and our end is over here. So what we're first identifying is we're going to do rise over run. When we rise, we're trying to meet this point. And to do that, we take only 1 jump. And that means that our change in y, or our rise, is only 1. So our change in y, change in x, is only 1. Now we're going to hop until we get to this point. It takes us 1, 2, 3. It takes us 3 hops to get to our end point. This means that our change in x, because our run is x, is 3. And now why, you might be wondering, why is when we go up our change in y, and why do we go to the right as our change in x? I'm going to draw your attention to these letters right here. When we're going up, we are going along the y-axis. We're moving along the y-axis. The y value is what changing when we go up by 1. We're changing from -8 to -6. Similarly, when we're running, we're changing along the x-axis. When we're running, we're changing from -8 to -2. And that's on our x-axis. So this means that our slope, or rate of change, is 1/3. This means that when x increases by 1, y increases by 1/3. And essentially what that means is that when y increases by 1, x will increase by 3, because 1/3 plus 1/3 plus 1/3 is 3, and that's 3 x's, because one change in y, which is 1/3 in this instance, is because of 1 x increasing by 1. Lastly, we have equation, which I will force you to only do method B, no matter what the situation is. If you do method A, I honestly do not know what to say. So our equation is f of x equals 3x plus 2. If you recall, in our previous video, I talked about how you're given a range of numbers or a inequality that allows you to choose which numbers to choose from. Here, because it is the slope, no matter what the x value we choose, it will always have the same rate of change or the same slope throughout, because it's a straight line. It will always be the same no matter what. So I went ahead and chose numbers 1 and 7, just because I wanted to show you exactly how crazy different numbers you can choose from. Remember, we can choose our x values because the slope is the same rate of change throughout. It doesn't matter if I chose 1 and 7, 1 and 17, 1 and 171, it doesn't matter. But when we're finding the rate of change, what we do is we identify our x1s and x2s, and we use those values to find our y1s and y2s. So to find y1, I substituted our x with x1. 3 times 1 is 3, 3 plus 2 is 5, y1 equals 5. Similarly, I do the same thing for y2 or x2. y2 equals 3 times 7 plus 2. 3 times 7 is 21. 21 plus 2 is 23. y2 is 23. Using our formula, y2 minus y1 divided by x2 minus x1, I plugged in each number into its corresponding spot, giving me 23 minus 5 divided by 7 minus 1, which equals 3. That seems like a lot of work for something that can seem so simple as just circling the number in front of x, and that is method B. In order to find the slope, or the rate of change, from a linear function, it is just the coefficient, the number in front of x. So in this instance, it is 3. 3 and 3 are the same number. So our slope is 3. So instead of doing all this extra math and extra work, just identify the number that is alone in front of x, and that's your answer. Now let's go ahead onto this practice problem. F of x equals 5x plus 3. You're done. Your slope, or rate of change, is 5. Hopefully that was very simple. Now I'm going to just go one more time through all of the 4 methods that we have, only using the slope method. First, we're going to start with our harder ones first. We're going to find the slope of 7, 9, and 12, 14. First, what we're going to do is we're going to give each one a name. I accidentally gave them i's instead of 1's. And we're just going to set them up from top to bottom. We're going to do y's on top because that's what our formula actually looks like. And y1 is 9, is to y2, which is 14. And we do the same for x. x1 is 7, is to 12. 9 plus 5 is 14. 7 plus also 5 is 12. Our change in y is that, and our change in x is that. Our formula is change in y divided by our change in x. 5 divided by 5 is 1. Our slope is 1. Next, moving on, we have an equation. Again, the answer is just the number in front of x, so our slope is 6. Next up, we have a graph. For our graph, we do rise over run. Our rise is our change in y, and our run is our change in x. And we would find these numbers out by doing our hops method, where we identify a start. I'll do down here. And our end, I'll also do down here. And we would hop up until we reach this line. 1, 2, 3. 3 hops. And we would hop until we reach this line. 1, 2, 2. So our change in y is 3. That's right here. And our change in x is 2. That's right here. This means that our slope is 3/2. And lastly, we have a table. We're going to identify x1, y1, x2, and y2, and we're going to identify the change in x and the change in y. 8 plus 2 is 10, 7 plus 2 is 9. So our change of y, which is 2, divided by our change of x, which is also 2, equals 1. This means that our slope is 1. Hopefully this video made a lot of sense to you. Hopefully this not only boosted your understanding of rate of change, but also introduced you to what a linear function and a slope was. I truly hope that this video was informational, and I truly hope that this series is helping you as much as I possibly can. Thank you so much for sticking around. This was Unit 2A, Lessons 1 and 2 of Algebra 1 Honors or Integrated Math 1 Honors, identifying the rate of change of linear functions and identifying slope from points, tables, graphs, and equations. Thank you.